All right, folks, welcome back. Just wanted to run through a couple quick examples today on factoring. And know, even though it's pre-calculus, not really a pre-calculus skill, it's something that we're definitely going to keep on using. So I wanted to run through a couple of examples of factoring and solving quadratics and kind of go from there. So I'm going to jump right into it. So the first one we see there, x squared plus 10x plus 24. Remember, when a is 1, if you just see as a plain old x squared, that's kind of the simplest case. So we're looking for numbers that multiply to be c that add to be 10. So if you know your multiplication tables, some of you can maybe can do that a little faster. But 24, so we know that 6 times 4 is 24, and that also adds up to be 10. So that's it. So that's your factored form right there. And of course, you can always go back and multiply that together to make sure that it equals the original problem. But that's your factored form. And then to solve, you just set each piece equal to 0. And then you get your solutions and you're all done. Okay? All of these things the same way. You do have to watch the sign sometimes. So like on the second one, we see that it's negative 30. So we want to multiply to be negative 30 and add to be negative 1. So again, go through the different lists of factors. We could do 1 and 30, that wouldn't work. 2 and 15, that doesn't work. 3 and 10, that doesn't work. But 6 and 5, notice that we had negative 6 and positive 5. That would multiply to be negative 30, and it would add up to be negative 1. So we got x minus 6 and x plus 5. And again, you can multiply that out to make sure. And then for solutions, and so we have x equals 6 and x equals negative 5. It is just a matter on these of just changing the sign and making sure that you write the solutions in the correct format there. One last one, and then we'll move on to the a equals to the a greater than 1 case. So again, same kind of deal, right? So x squared minus 8x plus 16, what multiplies to positive 16 but adds to be negative 8. So in this case, both factors would be negative. So it would be x minus 4, and the same thing, x minus 4. You could write that as x minus 4 squared. So it's the same thing. And then the solution, obviously, there's only one solution on this one. It's what we call having multiplicity. So it's a repeating root, so it only has that one solution. Real quick, I do want to talk about the special case because this comes up sometimes. So like if you had something like x squared, x squared minus 36, let's say, and we wanted to factor or solve that. Notice there's no middle term. It's really 0. So again, multiply to be negative 36. So notice positive 6, negative 6 would be 0 when you add them together. So here, your factors are just plus and minus. This is a special case called the difference of squares. And when you write your solution, you can just do plus and minus 6 like that. Okay? So that's the a equals 1 case. Sometimes a might not equal 1, but there might be a GCF that you can factor out. I'm not going to do a GCF example. I think you know how to do GCF, but just keep an eye out for that because sometimes taking a GCF out can make life a little bit easier. Okay? Now for the a not equal to 1 case, or usually greater than 1. This just involves a couple of extra steps on the beginning and then an extra step on the end, and everything else is exactly the same. This is a method, some people call it the AC method, some people call it the swing method, there's different names for it. But in any event, the first thing you're going to do is multiply the A and the C. Multiply those two numbers together and then just rewrite the problem with a plain old x squared. So we know 6 times 5 is 30. And we have that. Now we factor it just like we did before. So again, how do we multiply to 30 and get 17 when you add it? So that would be 15 and 2. So we have that. But now, so we're not done now, because clearly that does not equal what we started with. So the way I describe this, when we multiply the 6 and the 5, we kind of cheated, right? So once we're at this step, we need to undo we need to pay back our cheating, basically. So I'm going to go in here and divide both of these things by 6. And then what we want to do is simplify the fraction as much as we can. So 15 over 6, you can divide both those by 3. So you got x plus 5 over 2. And then same thing, 2 over 6. You can divide both those by 2. So you get 1/3. Now that's all we can do. So if you have something left over, what we do, this is why some people call this a swing method, because we take that leftover denominator and we put it in front of the x. And if there's a denominator in both of them, then both x's get something in front. So your factored form is going to be 2x plus 5 and 3x plus 1. And then to solve it, you still set the factors equal to 0, and then just get x by itself. Oops. Let's do 2x plus 5. And then just get x by itself. So subtract 5 and divide. And then subtract 1 and divide by 3. Okay? So exactly the same thing. So we do that little bit of cheating at the beginning, undo the cheating at the end, simplify, and then swing the denominators that are left over. I'm going to do one more example, then I'm going to turn you guys loose. So last one here. So again, multiply a times c. So in this case, it comes out to be negative 12. So we got x squared minus x minus 12. Factor like normal. So multiplies negative 12, adds to be negative 1. So that's going to be negative 4 and positive 3. Divide by the 2. Again, whatever that a value is. In this case, one of them simplifies. So 4 over 2 is this 2. So that factor is this x minus 2. And you're done. This one, we have the denominator left over. Can't simplify it, so it goes in front. So you got 2x plus 3. And then again, for the solutions, we're going to have x minus 2 equals 0. And 2x plus 3. So x equals 2. And then this one, 2x equals negative 3 divided by 2, x equals negative 3 over 2. So there is your brief review of factoring, both when a equals 1 and a is not equal to 1. Hope you found this useful. Go back and take a look at it. As we go through the year, factoring is going to come up here and there all year long, even in pre-cal and even next year in calculus for that matter. So make sure go through it and have those skills sharp for us. Until next time, have a great day.